Let's use this question to understand the concept of equilibrium of forces with respect to moment. So this question says in the diagram above, a rod 50 cm long of uniform cross section is suspended horizontally on a fulcrum F by the action of two forces. What is the weight of the rod? So this is the rod. The total length of this rod is 50 cm and is suspended by two forces. The first one is 200 Newton weight and the second one is 40 Newton weight. So they are asking us to find the weight of this rod. So since it's a uniform rod, the weight will act at its center. And where would you locate the center? The center will be, since the total length is 50, the center will be at the middle. The middle will be 25, 50 divided by 2. That will be somewhere here. That's where you have it. So here we will label it W, meaning the weight. So this is where the weight of the rod will act. And then the distance there will be what? 25. So it is this weight that we are going to calculate. Now we are going to use the principle of moment to calculate this. So first, for those who may not know what moment is, moment moment is defined as the turning effect of a force. Turning effect of a force. Okay, I don't know if I should expatiate on this or I should just go straight to solve this. So, in mathematically, the definition of moment is what? Force F times perpendicular distance from the line of action. So when you're talking about movement, you're talking about the tendency of a force to make an object or a body to turn or to rotate. Like you see, this body is suspended at point F here. I mean, this point is pivoted. It's pivoted at point F here, which means this rod can either tilt this way anti-clockwise or tilt clockwise. So when we are calculating moment, we are trying to measure to what extent can a force tilt a rod or a body to either to any side, whether to the left or right, whether clockwise or anti-clockwise. The principle of is applied in civil engineering with respect to loads, columns, and all those things. But here we are just learning preliminary knowledge of equilibrium. So that's what moment is about. So principle of moment with respect to this states that total clockwise moment will be equals to total anti-clockwise moment. What am I trying to say? If a system is in equilibrium, if a system that is suspended by forces and has a fulcrum or a pivot is in equilibrium, that means it's not tilting to this side or to this side. That means the moment or the total clockwise moment is equal to the total anti-clockwise moment. That's why it's not tilting. If they are not equal, this thing will tilt to one side. So that's the definition. So now what we are going to do is we are going to calculate a total clockwise moment and equate it to the total anti-clockwise moment. That's how we're going to find the force. So now this is what we're going to do. So on the left hand side, that's from the pivot or the fulcrum. There on the left hand side, how many forces are there? Only just one force, 200 Newton, acting in anti-clockwise direction. So taking moment of the anti-clockwise will be the force times the distance. That's 200 times the perpendicular distance. So the distance of the position of this 200 from the pivot, because the pivot is the consideration, is the point of consideration. because if this rod is to tilt, it will tilt from the pivot side, not from this other bit. It will tilt through the pivot, either to the left or right. So we calculate 200 times distance of the position of that force from the pivot. And so how do we get the distance from position of that force to the pivot? It's not 5, because the position of the pivot is 15, but the position of the force is 5. So distance from the force to the pivot will be 15 minus this 5. 15 minus 5 is 10. So that's 20 times 10 will be equals to, there's no other anti-clockwise force here. There's no other force that is bringing this thing downwards. So equals to clockwise moment. So the first force we see here is the first force we see here is the weight W. So the taking moment of that weight to be the weight times its distance from the pivot. So the distance of this weight is actually 25, and the distance of a pivot is 15. So distance of the weight from the pivot will be what? 25 minus 15, which is what? 10. So that will be the weight, or W, times 10. Now there is another force acting clockwise, which is the 40 Newton force. So we will now say plus. We take moment of that force also. So this will be 40. This will be 40 times the perpendicular distance from the pivot or line of action. So that will be now 45 minus 15, which is 30. Which is 30. So if you continue finish this off, that will be 2000 equals to 10 W plus 1200. So you collect like terms, 1200 will come to this side. You have 2000 minus 1200 equals to 10 W. So 2000 minus that is 800. So you divide both sides by 10 to make W the subject. So the weight there, the weight of the rod will be equals to what? 80 Newton. 80 Newton, option C. So this is how this thing is done. So you subscribe and you can book for online class. The link to my WhatsApp group is in the description. Thank you.